Okay, so now we're going to use that segments reference sheet that we had just covered, and we're going to actually apply it to pictures and learn about solving. So in this first picture, we are looking at AB is tangent to circle P, is what that's saying. So this implies the first thing that says if this is a radius, then we know that this is a tangent line. And they want to prove it. The way we're going to prove that this is 90 degrees here, the way to prove that is to use Pythagorean theorem. So if this is true, if is AB tangent, if this is tangent, then at corner A here, this has to be 90 degrees in order for this to be tangent line. So we have 5 squared plus 12 squared equals 13 squared. And to prove it, we square each of them, see if they're equal. Okay, and then we'll add the ones on the left. That adds up to 169. The ones on the right were 169, so yes. We can say AB is tangent to circle P because of Pythagorean theorem proves that this has to be a 90-degree angle. If these come out not equal, then this line technically isn't tangent and it doesn't make the right triangle. Alright, this one. So I'm just going straight in order of these. We've looked at to be tangent, that needs to be 90 degrees, so we use Pythagorean theorem to prove it. On this one, the tangent-tangent theorem says that these two have to be equal. So in this case, if these lines are both tangent, then we're going to say that this is equal to this. And we're going to solve for x. Once you find x, it wants you to plug it back in to find PQ. So we'll go ahead and solve this. This in this picture is when you have a tangent theorem. If you have two tangents, the two tangents should be equal if they meet at the same point. So let's do some subtracting here. You get 6x equals 18, so x equals 3. I'll plug it back in. It says for PQ, 14 times 3 minus 13. This is 42 minus 13. PQ equals 29. So basically your goal is to figure out what do you have in the picture, and then what theorem can we apply from our segment reference sheet. These were two tangents, so we set the two tangents equal to each other. This one and the next one are both actually everything in this picture represent tangents. Because let's say point B is here, BC or CB or CA, they only hit the circle in one place, so it creates a tangent. So we're going to apply that same idea that if the distance from C to the circle on both of those have to be the same thing. So this is 9.5. Same thing here. If EF to the circle is 11, ED to the circle is 11. And here, if AF is 16, then AB is 16. Now to find the perimeter, you just add up all your numbers on the sides. So add up your sides. And I got 73. There's no units, so you don't have to worry about like units. You just put 73. So same idea here. I know if AF is 5, AD is 5. We know CF is 14, then CE is 14. But over here I don't have either one of these numbers. So what you have to do is the whole length is 17. 17 minus 5 leaves this to be 12, which makes this side also 12, because at any given point it's equal distance to the circle. Now to find perimeter, you're going to add up all these outside numbers. And 62. Those are tangent lines on all those. Let's see what we have next. I just gave you big boxes to work in on these. Again, you have to know your vocab to know, is it a tangent, is it a secant, is it a chord? In this particular picture, we have two chords. Okay, so this is the one we called the chord theorem. It gets its name because you decide what is in the picture. We have two chords, so we're going to do the chord theorem. The chord theorem says you take part times part equals part times part. That means the two parts that make up the one chord, so like x and 10, we could do 10x, is equal to the other two, so like 15 times 14. 15 times 14 is 210. And we'll divide by 10 to get x by itself. So x equals 21. Now the next one is chord and chord again, but this one looks a little bit trickier. Here's why. So you still stick with like on one chord, what am I multiplying? So whenever you have a plus or a minus sign in a problem, go ahead and put parentheses around it. So when you do 4 times 5x minus 1, that 5x minus 1 is in parentheses. And the other way would be 6 times 6. So we have 20x minus 4, because we'll need to distribute. Then to get x by itself, we'll add the 4 to the other side. And then divide x equals 2. The directions on this one say find BD. So if I plug in 2 here, this would be 10 minus 1 is 9. So BD, the whole length would be 13. Alright, now these you notice extend outside the circle. If they extend outside the circle, that's called a secant. This is a secant and that one is a secant. So we have two secants in the picture, so we'll call that secant, secant. So the secant theorem is outside times the whole length should equal the outside times the whole length. We're referring to one secant at a time. So like on the top equation, not top secant here, 9 is on the outside. Okay. And then if I want to know the whole length from here to here is considered the whole length. That would just be x plus 9. Okay. So when I would write that, the outside would be 9 times the whole length of x plus 9. On the bottom one, this part is outside the circle, so we'll say 8 times the whole length would be 19 plus 8. And you can go ahead and, add that in your head if you want. You can distribute if you want. I typically just do 19 plus 8 and say the whole length is 27. So 8 times 27. So I'm going to go ahead and distribute this and say 9x plus 81 equals 216. Now we have to solve. We'll subtract 81 to the other side. So 216 minus 81 is 135. And then divide by 9. And I get 15. So a segment that extends outside the circle is called a secant. On this one, we have a secant, it extends outside the circle, but then we have one that's just outside the circle. The one that's outside the circle is called a tangent. So this is called the tangent secant. So those are the two types of segments we have. And I'm just copying this basically off that reference sheet. When you have a tangent and a secant, you do the tangent, the outside squared, so that would be 16 squared, equals the outside, which is 8, times the whole length, which would be 5x minus 1 plus 8. Or if you want to go ahead and add those two together, that would be 5x plus 7. Okay, to solve, we would want to distribute and square 16. I'm going to subtract the 56 to the other side. So 200 equals 40x. Then we'll divide. X equals 5. And it just says solve for x, so I think we're done. So recognizing the types of things. This is called the tangent on the outside. This whole thing is called a secant. This one we had 2 secants. The one above it, we had 2 chords. Alright, so these last ones are still applying the same idea. You have to recognize what you have. They just made it a little bit more tricky based on what we have to add or multiply together. So, this would be a secant. This is a secant. So, again, you do outside and then times the whole length. So in this case, the whole length, if you add x plus x, that gives us 2x plus 5 plus 1 is 6. So when I write this, the outside part would be x plus 1 times 2x plus 6. On the bottom, on the outside we have 6, and then the whole length of that would be 8. So, this is something we haven't multiplied much this year, but it was multiplied at some point last year. This is called distributing, or some people call it FOIL. X times 2x is 2x squared, plus x times 6 is 6x. Then you have your inside, you get 2x. 1 times 6 is 6. So I now have 2x squared plus 8x. 6 times 8 was 48, we'll just do that. And then instead of writing all that down again, I'm going to go ahead and subtract the 48 to the other side. So 6 minus 48 is negative 42. The reason I did that is because you want to set it equal to 0 to solve when you're doing a quadratic, which means you had to do factoring. We had x squared in our term. So we're at x minus this. 2 times 42 is 84, negative 84. And my middle number is 8. Okay, those are big numbers. If you want to make it a little easier, we could have started by dividing all these by 2, because they're all even. So if you want to do that, we can do that. Or we can sit here and try and figure out what numbers multiply to 84. They come out to 8. So 21 and 4 would work. Doesn't work to come up to 8. how about 84 divided by 2? That's 42, so that's not going to give me 8. 84 divided by 3 is 28. 3 and 28 is not big enough, so 84 divided by 4 is 21. Those are still too far apart, so 84 divided by 6 is 14. Hey, I think I got it. So if I want positive 8, I would need a positive 14 and a negative 6. That will work. I'll take out what they have in common. It's called the GCF. This one both have a 2x. This one you can take out a negative 6. So one parenthesis is 2x minus 6, and the other one is x plus 7. Set the first one equal to 0. You get 2x plus 6, so equals 6. And then x equals 3. The other one, x plus 7 equals 0. Subtract 7 to the other side, x equals negative 7. So those would be the two answers, so we need to try them to see if they would work. So JL is 2x plus 6. So if we did 3, that gives me 6 plus 6, so one answer is 12. Let's try negative 7. If you plug in negative 7, you get negative 14 plus 6. So that will not work because we cannot have a negative segment. So I'm going to cross off the negative 7 doesn't work. So JL is 12. Okay, so this one, very similar. Only this time we have a square root in our problem. And instead of having two secants, we have a tangent and a secant. So you have outside squared equals outside times whole. So if you take the square root of 174, and we're going to square that, the outside in this picture is x. This is outside. And the whole length would be adding those together. So 3x and x gives me 4x plus 5 is my whole length. Okay, when you square a square root, it just cancels each other out. So this is 174 equals 4x squared plus 5x. Again, when you have an x squared term, this is called a quadratic, so we need to set it equal to 0. I'm going to go ahead and subtract that number to the other side. And set up my numbers here. This one, unfortunately, is really big numbers. When you multiply 4 times negative 174, you get negative 696. And 5 is our bottom number. So, alright, let's see. 696 divided by, let's say, 3. That's 232. Okay, so 696 divided by 6. That's 116. 696 divided by, let's say, 81. That doesn't work. 696 divided by 9. 696 divided by 12. 12 and 58. Okay, so 12 and 58 are still a long ways away from subtracting to 5. So 696 divided by 24. 24 and 29. Hey, that works. So I would need to have a positive 29 and a negative 24. And you group the first two, group the second two. Those only have an x in common. And what do these two have in common? 174, can it be divided by 24? Nope, that's a decimal. So let's think, what else goes into 24? 6 goes into 24. So we're going to take out a negative 6, and that comes out to 4x plus 29. So one answer is x equals 6. The other answer, if I subtract 29, divide by 4, I get 7.25. Alright, let's see, it says solve for x. Hey, that's all I had to do. If you want to put it back in, if you look at this picture, x cannot be negative because x represents the part on the outside of the circle. So in this particular one, I'm only going to circle the x equals 6 because we can't have a negative side or a negative part of